Hey everyone, welcome back to another video of mine, where today we're going to be solving LeetCode problem 164 titled Maximum Gap. So before I actually start the description, let me just zoom in for you guys so it's a little bit easier to see. Actually, sorry about that guys. Yeah, that should be good. So, this is too much. I think this is good. So we're given an integer array nums, and we simply need to return the maximum difference between two successive elements within the sorted form of the array. Right, so if the array contains less than two elements, we simply have to return 0, and we must write an algorithm that runs in linear time, so basically O of n time, and uses linear extra space, or O of n extra space. So in example 1, we have an input array nums of 3, 6, 9, and 1. Note that this isn't sorted, we have to do that manually ourselves, right? And our output would be 3, because the sorted form of the array is 1, 3, and 6, and 9, and the greatest difference between two successive elements within an array is 3, either between 3 or 6, or 6 or 9. It doesn't really matter which indices you choose, because they're both equal to a maximum difference of 3. Right, so in example 2, we have an input array nums of just 10, right, just one element, and so our output would be 0, because the array contains less than 2 elements, so of course we have to return 0 using simply just logic, right? So based on the base case that we're given, let's just have a quick base case, right? If nums.length is actually less than 2, right? If that's the case, oh, sorry about that, guys. This is Python, I just realized. If the length of nums is actually less than 2, we simply have to return 0, right? This is our simple base case, nothing crazy. Right? If we don't have at least 2 elements within an array, we simply have to return 0, because it's simply impractical to compare elements that aren't even existent within an array. Right? So after we have that base case out of the way, let's actually start with our main chunk of the code. Right? So what I'll do is I'll actually initialize a biggest variable, and this is going to be set to 0. And what the biggest variable is actually going to monitor is it's basically going to look at and store every single maximum difference between two successive elements within our input array. Alright, and we'll do this like so. We'll say, for I in the range of the length of the nums of input array. Now we actually have to see if nums at I minus nums at I minus 1, right? So basically, if nums at an ith indice minus nums at the indice before it is actually greater than the biggest or the largest maximum difference that we've encountered so far, we can set the biggest equal to the maximum value of course, itself, and nums at I minus nums at I minus 1. Basically, the definition of the difference between the two successive elements that we're currently looking at in this one specific iteration. And one thing that I forgot to do actually here is actually nums.sort. Right, and this is basically because it simply says in the problem that we want to return the maximum difference between two successive elements within its sorted form, right? So that's the reason why I sorted the nums array, right? So just to recap what I did here on lines 7 through 9, I looped through all the indices of the length of nums, right? If nums at that ith indice minus nums at the I minus 1, or the indice before it, if that's actually greater than the biggest maximum difference that we've recorded so far, we can reset the biggest or the maximum difference to be the maximum value of course, itself, and the definition of a difference, nums at I minus nums at I minus 1, right? And this checks for every single ith indice or iteration of all the indices in our input array nums. Right, and after I've done that, I can simply return my biggest, because it will eventually have stored the largest difference between two successive elements, and this should work. And yeah, as you guys can see, it is just about as efficient as you can get, beating almost 100% of users, both in runtime complexity and memory complexity, taking only 706 milliseconds, right? If we analyze the complexity, this actually is going to be an O of n log n, because we're really sorting through the array and just scanning through it. And memory-wise, this is of course going to be O of 1, because we literally don't use any extra data structures or space to store any other elements from our input, and so this is going to be a constant time memory-wise solution. Right, so if you guys enjoyed that video, please make sure to subscribe and like to my channel. It really does mean a lot. And yeah, I'll see you guys in the next one. Bye-bye.